Just to preface the lecture, it's always good to have quotes from famous people saying how difficult it is to predict the future. So I've got two. One is from Niels Bohr, and he says that prediction is very difficult, especially about the future, the famous physicist. And the other one is Alan Kay, who's a computer scientist who's largely responsible for inventing the laptop computer. At Xerox PARC, he had the concept of the Dynabook, which was looked very much like laptops of today. And so he said the best way to predict the future is to invent it. And to some extent, that's what we try and do here at the HIT Lab, although we're making baby steps, but we're trying to give people exposure to future technologies and hopefully have them play a part in that. So there's lots of very interesting directions for research and where the wearable ecosystem, I guess, is going. And I'm just going to talk about 4 or 5 of them today. And then it'll be good to get some of your feedback as well. So first of all, just to give you a heads up about some new devices. So obviously through the class you've got some exposure to Google Glass, but that's only one of a whole ecosystem of wearable devices that's starting to come out. So I want to show you a couple of other devices. So this is a new one called the Copen Pupil. So Copen is a manufacturer that's been manufacturing displays for a long time. And one of the challenges with Google Glass, of course, is that when you wear it, it becomes quite socially isolating because people know you've got this device on your head and it looks strange compared to what people have already. So what they try to do is take one of their displays and put it into a eyeglass form factor. And this was just, actually I found this on the web just yesterday, so it's very, very recent. You can't buy this display, it's more a concept to show what you could do, because they want to basically partner up with an OEM and have them make it, and they want to provide the displays. But what they felt was that if a very small display in the corner of your eye, that's still very useful for providing constant notifications, and their motivational metaphor for interaction with this was really around voice interactivity. So if you had a small display with a microphone, then just like what Google does, probably a lot of what you could do could come with voice interactivity, or maybe add a touchpad on the side. So I've got a little video here of the guy talking and showing it. And let's see how we're going with audio. So this came out like yesterday or the day before. So he's actually, so I should pause. He's actually wearing the display on his head right now. So you can see it looks like kind of a pair of Joe 90 glasses, but you know, if you walk down the street and saw him with that on, you probably thought he's got goofy glasses on, but you wouldn't really think necessarily that you know, it wouldn't be as socially isolating perhaps as wearing Google Glass. Yeah, that's true. Yeah, so so he'll this is the CEO of the company, and he's going to kind of tell you a little bit about what the display is about and their motivation for doing it.
In fact, it's completely hidden by what we use it inside of any such bypass market. Tell us a little bit about it. What's inside these glasses?
This glass is now it has a computer on one side, on the arm over there, and Max is on the side. All the speakers are hidden here, and then the microphone is over here and the microphone over here. But most importantly, there's the optics. On the optical engine, it is inside the frame. You look at it and voila, you can see a regular TV screen. So now you have everything you want. You can speaker, you can audio, input, output, as well as visual input.
Okay, so unlike something perhaps like Glass where you have the touch bar and side control, the idea with this is that it's all audio control. So I've got microphones and I've got a system of noise cancellation, so then you can all the background noise and headset into it.
That's right. In fact, it was specially built so that you can cancel all the noise outside. You only monitor the from the outside. So you either give a talking about it, you never
Okay, so there you get is an overview perspective. So you can see that there'll be a number of other devices coming out in different form factors. So and the focus on having an audio interface is probably quite interesting because you can have very small earbuds and the like and still create this kind of audio surround. I'll talk about that in a bit in terms of research directions. Another interesting company is one called GlassUp. GlassUp again are focusing on a very much a glass form factor, and their focus is using this as really as a secondary mobile display. So the idea is that you could have quite a low amount of computing in your glasses if you tether this to a mobile phone, and the mobile phone does the data and communications for you, and then all of the glasses are showing is alerts and notifications. So you know, instead of having the People Watch or some other device showing those things, you can see them in your corner of your eye. And they also have a touchpad on the side as well. But I've tried the early version of these out, and they've got still got quite a long way to go. They've got a quite small sweet spot where you can actually see the display. But the form factor was pretty much like this. So I've got a video, a concept video from them showing what they, how they see their system working.
Every day we get more information through our smartphone, but it is a pain to access it every time. We would rather see these messages as they come than doing anything. At times, we leave our hands free, or we read the message immediately, or we can't look elsewhere. With GlassUp, we make all this easy and immediate. Users will read decades wishing to read emails, text messages, Facebook status updates, tweets, calendar events, stock market values, breaking news, salesmen, joggers, sailors, motorbikers, deaf people aiming to see the works of their friends easily. People at theatres, cinemas, museums, tourist places.
So I'll fast forward this a little bit. They're basically saying that everybody in the world is going to want to use their technology. And then you can see this talks a bit more about the technology itself. And what they have basically is a micro projector in the corner that's and then so here's the micro projector here. Then it projects onto a kind of holographic element that's on the lens itself in the glasses, and then you can see the image from there. So it's a little bit like what Google's got here, except it's moved into the corner, made smaller, and then projecting onto the glass of the glasses themselves. So they'll talk about that now.
One-day battery life. Easy to use with its touch control. Compatible with all existing smartphones. Soon September 2013.
And that was kind of a lie, but anyway. And I think that's everything. Yep. Long list of credits. That's right. Okay, great. So they did a Kickstarter project last year, and they didn't reach their funding goal. But they're still working at it. So I've got the website kind of gives a current snapshot of where they're at. I can find that. Yeah. I think I've gone. It's gone. Let me just copy paste from here back. So it was an interesting form factor, and it was much more glass-like than Google Glass is. But when I tried it, it still had a lot of work to do in terms of the display. And people, I think, underestimate the cost of or the difficulty of what it takes to get something to market. So just seeing something prototype in a conference is still probably $1 million and 50 or 60 people years of work to get that to the market. Anyway, I guess, and apparently you can pre-order them right now. So look at that. Yeah, so $300. I'm not sure how long they'll ever deliver on, but anyway. Okay. So that's, and then another one I've found recently which is very interesting is this project called Telepathy One. And Telepathy One is even smaller. So it's similar to the Copen display, and you've got the small display in front of your eye here, and this headband kind of wraps around your head. And on the other side, you've got a camera here as well. And the guy who founded this it's a kind of a Japanese eccentric millionaire, and he developed one of the most popular mobile apps in Japan called Sekai Camera, and it was an augmented reality social app that for a long time was the #1 in the iOS and in the Android store in Japan. So he took his money from that, and now he's built this system, which is still prototype stage, I would say. But his idea is, he called it Telepathy One because he really wants to focus on how this is really a device for remote communication and connection. So, you wear this around, and then your friends see what you're seeing through the camera and give you feedback as well. So it's not so much focus on the hardware platform or doing a lot of onboard processing, but it's more about the communication connection. So he's got a lot of interesting material on his website about his philosophy around that, and he's grabbed quite a lot of attention. So here's the Telepathy One site, and we can watch the video here. So this is visiting a location in Japan, and then you're in the corner you can see the view and stream that to a remote person. Turn off my Skype so I keep on getting annoyed by. So it's very glass-like, I guess you'd say. But it's very wearable. And then he's streaming that remotely to his friend, and presumably she's helping him pick out stuff or share stuff or something. And sending comments back, and then he can see the comments there as well. So there's nothing you couldn't do right now with Glass, but the form factor is a bit different, and it's focusing more on social communication rather than with Glass. It's trying to be an overall platform, I'd say. Of course, these are just some examples of a broader trend towards wearable devices. And so here's a screenshot I grabbed from somebody else about how in the future, well, currently we can get all these different devices on the market that let you be well connected. So there's Google Glass, there's Nike Fuel Band, Fitbit. In fact, I've got a Fitbit, an older version of the Fitbit here. So this is I wear on my waistband that tells me how many steps I'm making every day and helps me exercise. A variety of headsets and watches, and then even for your dog, apparently, there's this attaches to the collar and records your dog's activity. So I'm not sure why you want to do that, but anyway. And I think in New Zealand right now you can buy the Galaxy Gear. Have you guys seen that at all yet? If you go to the 2 Degrees store in Riccarton Mall or somewhere, I went to one actually when I was in Auckland last time, and they had it on sale there, and I asked the guy how many he'd sold, and he said none since they've had it for about a month, so I'm not quite sure how it's going to take off in the market. Really? Wow. Yeah, I think you have to have a Galaxy 4, and I think the 3 was pack ranking as well, but yeah. So there's been, I would have to say the reviews in the market are kind of mixed. I've got a little video that shows it working though. And it is a full Android computer on your wrist. Just go to the videos and see. So for those people that don't want to have a, where is it? $400 basically. There we go. But you better have a Samsung phone if you want to get full value out of it, because it does only pair with some Samsung phones.
Galaxy Gear is one of the first new generation of smartwatches. It's an Android-powered watch that talks to your phone and lets you do lots of things that you can sometimes do on your phone, but without having to take your phone out of your pocket. So it's controlled by swiping through all these different home screens, such as you've got your photo gallery there, you've got your music, you've got your pedometer to track your footsteps, so if you want to keep track of your health, it's your setting there. And here's your other apps as well. There's going to be 70 apps at launch, such as Find My Device, which allows you to find your watch by just pressing a button on your phone or vice versa. So one of the things you can do with the Galaxy Gear is you can make phone calls without having to even use your phone. So you can either do that by going into your contacts, or you can actually dial a number right here on the watch itself. The default home screen shows the time and the temperature and the last time it was updated, but you can also change it to have different types of watch or show things like your calendar information right there on your wrist. So when you swipe down, the Galaxy Gear also has its own camera, which allows you to take photographs and also short 10-second videos. You can wear the Gear as a watch on its own, or you can connect it with a Galaxy device.
I'll pause that there. So this is the, and of course there are a number of other watch-like devices on the market. Most notably the Pebble, and there's rumours that Apple is producing their own watch, and Samsung has a watch as well. So for those people that don't want to wear a headset display, the wrist is the next nice location because you can easily look at the wrist as well. And then you've got a variety of different performance tracking devices and activity tracking things as well. So I've been using the Nike Plus for a while until it broke, and I found it really, really helpful because it motivates you to do more activity. And it's not so much you wearing the device, it's you connect back to the website and then your whole social network. And so, I'm track my number of steps I walk every day, and I can see how my friends are doing, and that motivates me to exercise more and everything like that as well. So you kind of have this whole device ecosystem which is emerging now, where you've got some devices that are worn close to the body, like clothes that have sensors in them, GPS tracking, things like that. Some devices on the body, like electronic glasses, and then you've got devices that are in the body as well, like smart pills and implants, things like that as well. So you'll see a lot more trending to that in that space. And many of these have the same wearable attributes I talked about at the beginning of the course, where they're hands-free, they're always on, they're environmentally aware, they're connected, attention-giving, and have a good development platform as well. So once you've got all those devices, then there's a lot of interesting research that can be done in terms of input techniques and user experience. So many of you have noticed now using Google Glass that it has some limitations in terms of input. You're either going to be touching on the side of your head, or you're going to be using voice, or you can connect to another device and use that. So there's another interesting ways you can think about input going beyond just what Glass provides. So one is by using other Bluetooth devices. So there's a company called Remote, and what they do is they're providing a Bluetooth-powered remote control for Glass. So the idea is you have this in your pocket, and you can get access to all the Glass menus and everything by using that, but you don't look silly by holding this on the top of your head like that. So let me show you a little video of their system working. I'm not quite sure where they're at. They were doing it through a Kickstarter, and I don't know if they raised their funding or not, but it's so this shows you the demo of it working. You put it onto YouTube because it's a bit slow there. Okay. So.
Hi, Kickstarters. I am Phil Gonzalez, and this is Remote. Remote is the first remote control for Google Glass.
As you know, you can command Google Glass through a touchpad that is located on its side. This allows users to control the device by swiping through a timeline-like interface displayed on the screen. It is also possible to do it by using voice commands or the My Glass app. Now you can also do all of this with Remote, the first remote control for Google Glass. Remote has a linear and a circular touchpad that allows you to browse the timeline, take pictures, and record videos. It truly gives you full control of your glass, right in the palm of your hand, in a very comfortable, intuitive, and easy-to-use device. It is equipped with several sensors, buttons, buzzers, and a vibration mode. Remote provides source code examples, libraries, and documentation for iOS and Android to encourage developers to create new and interesting apps easily, quickly, and with high integration level. Remote is compatible with a wide variety of professional sectors and industries.
Remote would be actually perfect for my presentations. I could be seeing one thing and having the public see a different thing, all without disrupting my connection with the audience.
Remote also has sensors, which means more sensors, right? More fun. Remote actually interacts with the interface of Google Glass, which means less of this and more awesome.
People with disabilities and problems with mobility. Or users who simply want to enjoy glass at home or everywhere.
When I get home at the end of the day and I'm sitting on my couch, I would love to be able to use Google Glass without my voice commands or without raising my hand. Remote would be perfect for that.
With remote, you can take pictures, listen to your music, play games, or much more.
Tablets, smartphones, PCs, and even compatible smart TVs and smartwatches can also be used with remote.
Google Glass will be launched soon, and we need your support.
Would you like to be part of this project? Help us to make this dream come true.
Thanks for your time. Keep connected.
There you go. So I'm not quite sure if they've reached their funding goal or not, but some of the use cases are quite compelling. I mean, it would be good to be able to be walking in the street or in a public setting and be able to have access to glass without having to do this kind of on the side of your head. The other interesting thing potentially is that if they've got another set of sensors in the device itself, so that means now potentially you could detect the hand orientation separate from the head orientation, and you could do some interesting UI stuff from that perspective as well. But I'm sure you'll see a plethora of other devices like that coming onto the market as a secondary market, because most wearable devices support Bluetooth, and so it's very easy, as I guess you've been thinking about, what we've been talking about here is take an Android device or Arduino board and Bluetooth data over to glass and use that to control the system in some way as well. One of the areas that I'm particularly interested in personally is more non-visual interfaces. And about 15 years ago, there was a project done at the MIT Media Lab called Nomadic Radio, and by Nitin Sawhney. And the idea with this was, what could you do if you didn't have any visual display at all? And so he had this kind of neck yoke that you can see here. It's a little bit strange, but there was two speakers that were basically below his ear pointing up, and then he had a microphone there with speech recognition in it. And then this is all wirelessly connected over to a small wearable computer that was doing all the processing. And the idea was, once you've got this, these speakers, you could create a surround audio experience and then use that to help manage your information. So he had a really great audio interface that combined spatialized audio with auditory cues and speech synthesis and recognition. So you would, when you're listening, you kind of heard this sound of a flowing river. And then when you had email that would come in, or you had other messages that would come in, you would hear splashes falling into the river. And you could also, they were displayed in this circular way here to give spatial information. So if I got a voicemail message, at 10 o'clock in the morning, then it would be over, where is it? I guess not shown here, but over in one part. And then as I rotated my head around, I could hear the other messages people left at different times of the day as well. And he also had a very interesting, one of the challenges with doing audio is that audio, unlike visual cues, is serial. So, you can't, it takes a long time to listen through an audio message, whereas with your browsing through information visually on glass, you can see the message very quickly. So he had a very interesting way you could do a technique called audio skimming, where you could skim through the audio messages and you'd hear about 3 or 4 seconds from each message, just so you could know if it was what you want to listen to further, or just recognize the voice and listen to it in more detail as well. So I think there's a lot of potential. Once the displays become smaller and smaller, as you're seeing with some I showed you before, there's also a lot of potential to use the audio interface more as well, and have a rich 3D sound display that would enhance that. And in many ways, that's very unobtrusive. With today's technology, you could easily have some headphones that stick in your ear, and people wouldn't think anything about it if you're walking around with headphones on, because it's similar to music or something like that. So, on a bit more technical level, one of the things that we do here in the HIT Lab is we do a lot of augmented reality work. So I want to show you a kind of a snapshot of some visions of AR, and then talk about how some of that is coming to wearable computing as well. So just to set the scene, this is a, let's see here, this is a, here we go. a clip from the Iron Man 2 movie, and this is made by a company, Prologue Films, that did a lot of special effects for Iron Man 2. So this is their promo clip, basically. And I guess you see a lot in science fiction movies, different visions of the future, and oftentimes they inspire research that we do here in the lab or in other places as well. So here's the Iron Man's, or Tony Stark's lab, and he's got this kind of sort of projection screen going on here. And then he's got this technology where he can overlay computer graphics onto this real model of the city, and then he uses now his gestures to start interacting with the graphics. So you can reach in and pull objects and manipulate them around and things like that. So what he's trying to do is design his new Iron Man suit. I guess a lot of you saw the movie, so you know the scene. And supporting very rich interactions. Okay, I'll stop there. So if you want to make that vision real, I mean, that's very compelling compared to how people design today with sitting in front of the keyboard and everything like that. So if you want to make that vision real, there's lots of different requirements. You'd have to have some sort of display, and you can't see him wearing anything, so maybe he's got contact lenses in his eyes. You have to have some sort of way to track your hand in space or your body interactions in space. There's it didn't show it in the clip, but there's some speech inputs that he's got going on there, and also some sort of intelligent assisting on the backside. And of course, most importantly, you have to tie it all together in terms of providing very good usability. So at the HIT Lab, some of the projects that we're doing kind of feed into this vision as well. So I'll show you a couple of examples, and then I think today you'll be able to get some live demos of some of them as well. So first of all, environmental sensing. So you saw he could look at the real model of the city, and then you could see virtual content overlaid onto the model. Oh, why don't you come forward, guys? So we've got some visitors from University of Victoria, and but I think they want to hear what I'm going to say. So I'll just introduce you briefly. We're teaching a class here about Google Glass, and so you guys are more than welcome to hang out at the back for a little while, and when I finish I'll give you some more. But if Gun over there, who's sitting back down there, he can help you get some chairs, and then I'm talking now about kind of the future of wearable interfaces and augmented reality, so it's kind of interesting what you're doing. So grab a seat at the back there, and Gun will get you set up. So in the lab here, we've been working for a while on some computer vision techniques that allow us to capture the real world and then display it back to people as well. And so with technology like Microsoft Connect and with a variety of depth sensing, you can do that. So one of the projects we developed was called this AR micro machines. And the idea was that you could put objects in the real world, and then you could capture them with a Kinect camera, and then you could create a 3D terrain model of those objects and then race virtual cars in the real world. So it's really a technology demonstration to show how you could have real-time capturing and display of the real world. So let me show you a little video of this working. And I think some elements of it today you may be able to see for yourself. Here we go. So I'm going to fast forward a little bit here to this part. Well, I guess I'll show you I'll fast forward to this part first of all here. So here we go. Some of you may, if you're as old as I am, may have played the game Micro Machines, which was based on the Micro Machines toys and then the TV show, I guess. But the idea on the PC was that you could have very miniature cars that would race around the real world, and then on the PC game, you'd have these cars that would race on a desktop and hit into pencils or things like that. So we want to build an augmented reality version of that same game. So here's the real world, and you can see a few objects like the Rubik's Cube, and there's virtual cars here as well. And then when I put play here, you can see how that we can now drive the cars in the real world, and they'll collide with the real objects and car shadows, things like that. So there's some physics, so they can hit into each other here. And you'll see some occlusion, so when the virtual car drives behind the real block, it gets covered up and occluded by the block as well. And the goal of the game was to try and build your own race course out of real objects yet around you, and then race your cars on the race course. So he's got a ruler here, and he's trying to drive that up. here, and the physics isn't very accurate, so you'll see the cars kind of stick on the objects, but it's really, really fun though. Just try and get over the Lamborghini's not going to make it. Oh, it crashed. And there's some simple gesture interaction as well, so you can poke objects with your finger, things like that. So this was done about 3 years ago, and what's happening is that the Connect above is capturing the world, and there's also, because it's doing real-time capture, you can interact with the world in real time. So this wireframe you can see now is the white image, shows what the Connect's seeing, and now he can grab the cube and start moving it around, and it updates about 10 frames a second, so it's providing pretty good realistic feedback. So you can see from the video with Tony Stark where he had the real city model and he had the virtual city overlaid on the real model. You really can do that now. And we might be able to show a version of that demo today if Tham... Do you know, David, do you know if Tham is coming today? Okay, great. So, of course, you don't just want to be able to see the world like that, you also have to want to interact with it as well. So the other thing that Tham's been doing is looking at how you can use bare hands to interact with AR content. So you can reach your hands out and manipulate them and move them around. And so let me show you the first part of that video. We kind of filmed it backwards, but and that shows how we've implemented some of that as well. So in this case, now we have a Connect above that's tracking your hands. We use the Connect and also skin detection as well, so you can extract out, and then you can now he can pick up the virtual ball with the real hands and pour it into this cup here. And the occlusion is not quite right, but again, that was 3 or 4 years ago, so we fixed that now. And now you can push the cup down here, and there's some physics, so you can poke it out and things like that. You can also interact with multiple hands as well, and so use the computer vision and segmentation to find all the hands, combine that with the depth information, and now you can have multiple people interacting with things together. So you can see again the white frame overlaid on the real hands here, and that they're all pushing and playing balls together. So that's what is available with Connect right now, and then what you can also do is bring this to mobile devices. So there's a company called Meta. Have most of you heard of Meta? Maybe not. So Meta is a startup company that came out of Columbia University, and they're combining a depth sensor with a stereo 3 see-through display to enable you to have gesture interaction with wearable systems as well. So let me show you the video of Meta, and let's see here. Yep. So a lot of this is faked up, and you see they're quite bulky devices now, but the new versions are smaller than that. And so now they're playing chess together just by using hand gestures. Now she's sculpting with her hands, and then she can take the form she sculpted, and she can put it directly onto a 3D printer, and the 3D printer will then create the form right away. And now it's printing out the form that she's made as well. There it is. This guy's in the meeting, and face recognition and something like that. Of course, they don't address the problem that he looks like an idiot wearing this big stick on his head, but anyway. So they have raised several $1 million now of funding, and they are developing. I tried a prototype of this about a year ago, and I have to say it was very rough. But now it's going to progress quite a lot more from that point they showed a year ago. What we're doing in the lab here, I hopefully got from the earlier message in the course, is that we're very interested in rapid prototyping. So what we've been doing in the lab is we've been prototyping gesture-based interactions as well. And with glass right now, you can't put a depth camera on here, they're too big, although Intel has a very small one that they'll be releasing in the market next year. But you can prototype the interactions you could do, and so that's what Hugh Dong's been doing over at the keyboard. So he'll show you a demo a little bit later today of that, but I'll show you our setup, and I'll talk a little bit about it, and you'll be able to see a live demo a little bit later on. So we've been using a system from a company called 3Gear, and 3Gear uses a single Connect camera to create full 3D hand models of both hands, and also most importantly the inverse kinematics of the hands as well. So we've got a setup where we have a 3Gear system doing the hand tracking, and then you can take the hand information and send it over to another system that either you can send it to Google Glass and you can see your hand on glass and use that for real interaction, or to a PC as well. So in the first case, here's the PC version. So this is the second generation, I guess, of what I showed you first of all with the hands interacting with the balls. And now using head-mount display, you can see your hand in 3D, and you can reach out and grab objects and start moving it around. And now you've got a two-hand input with the skeleton as well. So let me show you a video of that. And I think you'll be able to see a live demo. Actually, David, can you ping Tham and just make sure he's going to be here today? Send him a message on Facebook or something. Oh, you don't have to leave the room, it's okay, but just on your computer you could just send a message and see. And ask him if he can show a demo a little bit later today. That'll be great. So let me show you the video of that. Oh, okay. Just see if he's coming for lunch, and if we can show a demo of this after lunch, that'd be great. So I'll show you that this is very new work we've been doing in the lab here. And so here's what you see through the display. You can see your hand. We're using an Oculus Rift display, so it's got stereo cameras on it, so you see the hand in 3D video, and then you can reach out and interact with objects. The little dots here on the fingertips, that's actually where the 3-gear system thinks your fingers are, so there's a little bit of offset there. And then you can reach out and grab and move objects around as well. The main difference between this and... Oops, that's somebody calling me. The main difference between this and the other system I showed you is that now we have a full articulated hand model. So you can see now the virtual hand is overlaid on top of the real hand. There's still some misalignment, but what that allows you to do is much more complicated hand gesture recognition and map that to different commands. And so what Hudong's been doing is looking at how you can use this for very rich gesture interaction on glass. And he'll show a demo of that a little bit later today. So you can imagine you want to see your hands in front of your face and reach out and do menu commands or interact with objects as well. So he also will have the ability to do sculpting, a little like what they showed in the space classes video. You'll see that just coming up next, I think. Let's see. I'll fast forward it to the sculpting part. Yeah, okay. So we can now pinch with your fingers, and you can make a curve in space, and then it rotates the curve around, makes a volume of revolution, and sculpts out the object. Unfortunately, he's left the physics on, so all the objects start bouncing around. But anyway, and I think this afternoon we have to try that for real, and you get a feeling for that. There is, though, some of you who've played with the games on here, you may have noticed there's one game on glass that does use gesture input. Did you play the, I guess it's kind of like the Fruit Ninja game, but has any of you played that on glass? So if you go into the game menu, there's one game where you have to swipe your hands either left or right, and you can in fact, I guess I can probably, I won't show it, but you can try it for yourself when you get the games fired up. And it does very simple, because the process is quite slow, relatively slow, then it can only do very coarse computer vision processing, but it detects whether your hand's coming from the right or the left, and it cuts fruit in half depending on where you got the right or left hand. Did you call him?
Yeah, he will come around 12.
That'd be great, yeah. You can have some pizza and then we can, that's perfect. So that's gesture input. The other area that we're interested in is combining that with speech. So it turns out the gesture is good for some things, but it's not good for other things. Like if you want to, for example, specify quantity, how do you do that? You hold like 5 fingers up or something. So we've been doing work here in the lab on how you can combine speech and gestures together. And of course, the glass user interface is always quite speech-centric. So you can imagine a case where you could point with your finger and you can say to glass, what's that? And then it will tell you what the object is, or point at a piece of text and say, translate that, or something like that. So we've been building systems where you can combine speech and gestures together. And one of those systems, my student got there. Well, it's not technically that difficult, but there are a few tricky parts to it. So you can have a depth camera that provides video input, and then you've got the speech input. But the most important part is this multimodal fusion module here. So when somebody says, what is that? The only way to understand what they're saying is combine the speech together with the gesture that have all been time-stamped to make sure that they're happening at the same event. Now, it turns out there's some interesting things around this. What she discovered was that people actually start making gestures before they start speaking. So before I say what is that, I'll start moving my hand up to start pointing at the object. So by tracking the gestures, you can get a clue that there's some speech coming, or it helps you understand the speech as well. So she did a little user evaluation, and I'll show you that in this case, the task was to, you saw a set of objects here, these white, the colored objects here, and the goal was that you had this this blue object here, the ball. You had to make it look like the target object, which is the pink cone there. And you could do it by using either speech by itself, or gesture by itself, or a combination of speech and gesture together. And there's some primitive colors there and objects there. So in this case, you would, if you're using gesture by itself, you would make a pointing gesture, and that would cast a virtual ray out from your hand. It would and you could collide that with the blue cube, and it'll make the object go blue. You could then cast another ray out to change the shape, and then you could grab the object with your fist and move it where you want to move it. So let me show you a video of this working. Okay. So this was done a couple of years ago, and she's now graduated as a PhD. Here's the setup. It's a depth. There's no connector available at the time, so we use this other camera here, and the task was to change the color of the object or shape and move it to target position.
Left.
So it's using speech by itself, and this is turns out really difficult because you have to keep on saying left, 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 left.
Left. Green. 2. Down. Right. 4. Green. Cone. Left. Down.
So now this is using gesture. Now it's much faster. You can just reach out with your hand to grab the object, move it over, and then point at the color you want and the shape you want. We did some tricks also to make sure that the hand was segmented and it appeared over top of the real world. Nothing breaks the illusion of AR more than seeing the AR content appear on top of objects it's supposed to be behind. So we did some tricks with that. And now you'll see the final version, which is speech gestures together. Now in this case, the advantage is that you can issue some speech commands while you're making the gestures as well. So you can pick an object and you can say red, and it changes to red while you're moving it. So you can see it change it to yellow, and then it changes, so it's much faster. Okay. So what we basically found from that is that the multimodal interface is much faster using just by itself, and users overwhelmingly preferred using the speech and gesture together. So 70% of the people said that that was their first choice compared to using speech by itself, and only 5% by using gesture. So there's things like this show that in the future people will get much more powerful usability out of combining multiple modalities together. The other thing I want to talk about is contact lens displays. So in the concept video shown, the Iron 2 video, there's no display he's wearing. So maybe he's wearing something like a contact lens. And so this is the work that Babak Parvaz was doing at the University of Washington. And he's really important because Babak Parvaz, while he was doing this work, got recruited by Google and then headed up the Google Glass project. And then just recently, so at the University of Washington, he was able to use MEMS components to build a micro display that fits into a contact lens. So here's an example of that. So essentially you take the contact lens, you groove it up really smallly, and then you wash it with components, and the components self-assemble into the lens. So there's some challenges here around miniaturization, assembly, and of course being eye safe. If you put this in your eye, what's going to happen over time? So that's the concept. This is actually what they look like. They've been made for real, and this is the lens in the display. Oh, this one here has an 8x8 element of LEDs on it. So it can actually be used to display colors and the like. And this is what it looks like in the eye of a rabbit in this time. They did some trials with rabbits to see how long they could leave the lens in the eye before they started causing irritation. And he told me that they were left in there for about 20 minutes, and the rabbit showed no example of irritation at all. And so Babak was the head of the Google Glass project at Google, but about a year ago, maybe 8 months ago, he stood down from that position, and he now, about 2 months ago, some of you may have heard the announcement in the news that Google has now released out of the Google X Labs, the same labs that Glass is in, a blood sugar level glucose monitor that fits into a contact lens. And so Rebecca's doing that. So he basically started off contact lenses, started the Glass, grew the project to be a pre-commercial or commercial product, and then wanted to get back to research. So now he's gone and moved sideways and is doing research again. So that's technology that will come. Obviously, it's going to be a long time before it actually becomes really usable. But you could use technology like this for, and what Google's doing now is monitoring blood glucose for diabetes and other types of health monitoring as well. Some of the other research we're doing in the lab is around intelligent feedback. So it turns out that you don't just want to have AR systems or wearable systems, you want to have a lot of smarts behind it at the back end. And this is a project I did in collaboration with the computer science department here, where we took an augmented reality viewing view. We combined that with an expert tutoring system that told you how to show information to help you learn the best. And we found that by doing that, people were able to learn and retain about 30% knowledge more than just by using AR by itself. And I didn't sleep the night before last because I was applying for funding from the Ministry of Science and Innovation to fund this project further with Tanya. So if we're very lucky, we'll get $1 million from the government to make this real and potentially combine some of that with Google Glass as well. So the last thing I want to talk about before I hand over to Gunn, and he's going to talk about more about actually making augmented reality real on glass, is scaling up. So you can see with Google Glass, you've got, and the other devices I've shown, many have cameras on them, so they provide this ego vision collaboration. The video you saw from Telepathy 1, where he was streaming video to his friend. So you could imagine that provides a new opportunity for remote collaboration where you can see what your friend is seeing and help collaborate with them as well. But there's lots of interesting research questions around that too, though. So for example, how do you capture the environment the person's in? How do you provide good quality service? What visual and audio cues do you want to best experience? How do you interact with a remote user? How do you measure the quality of the collaboration? And one of the areas that I'm interested in is what happens when you do that on a bigger scale. So if you combine wearable computers with another new trend which is happening now, which is human computation. So some of you may be familiar with the Amazon Turk machine. So for example, if you want to, if you have a task where you need to count the number of people in a picture that have a, in New Zealand, the cricket, most recently, Tui had the very successful campaign where if you catch the ball one-handed at one of the cricket games, you get $100,000. So they might want to know how many people are going to the stadium wearing the Tui shirts. So maybe what they want to do is they want to take a picture of the crowd and then count all the people in the picture wearing Tui shirts. Well, that is a quite challenging computer vision problem to some extent. But Amazon has a service called Amazon Mechanical Turk where you can send images and you get real people to perform these micro tasks for you. So Tui takes a photograph of the whole stand, sends the picture to Amazon Turk, and they say that we'll pay you 50 cents for every picture you complete. And then Amazon has a process where they send the picture to presumably some people in India or in Southeast Asia or some other country where it's low cost labor, and somebody sits at the computer, counts all the pictures, and then sends the result back. So that's an example of a human computation where you've got a real human who's doing some sort of skilled task. I did an experiment on that once when I was preparing for the slide for another talk, and I found a street sign on the road. I guess this is Chinese. Can you read this, Hudong? Slow. Okay, great, excellent. So another example of human computation. But as an experiment, I took this picture and put it on Facebook, and I said, what does it say? And within about 10 minutes, or 5 minutes, I think I had one of my friends on Facebook was Chinese, said this is what it means. So you can imagine a case where you're walking around the real world, you've got your Google Glass on or something like that, or maybe you're driving around, your car breaks down, and you don't know what to do. So maybe there's some sort of human computation service where I can call up and say, what do I do? And there's a mechanic somewhere in the world who's able to connect up to me and guide me through fixing what I'm trying to do. So that's where you can get the benefit of scale, where you have a social network combined with wearable technology, and at the back end you've got potentially millions of people with the right skill set you can tap into. And there's work being done on this already, not necessarily with wearables, but with phones and other things like that. So there's quite a lot of work being done in human computation now, where you've got mobile users that have some sort of app on their iPhone or iPad. They send to a back-end task here that a task assigner that automatically assigns the task to a remote person somewhere. The remote person gets the task, performs the task, and sends the results back to you. So maybe I'm in China, and or in New Zealand for that matter. I'm looking at a Chinese menu. I can't translate or read the menu, so I take a picture and using this app, and somebody in China translates the picture, sends me the menu options back, and they get paid $1, and I get my menu translation done. So there's been a lot of work done in this space around mobile apps, but there's been very little now done with wearables. But this will be the next trend happening on in the future. The last thing I want to talk about was scaling this up on a much larger scale. So this is, I guess, Professor X from the X-Men, and in the second or third movie, he had this special machine where he could put this helmet on, and the helmet showed him every person in the world and how many psychic abilities they had. So these white glowing things are the people, and this was enabling him to identify all the mutants in the world that had special powers. But you could imagine, and this is kind of science fiction, but you can imagine if we were able to track the activities of millions of people, then you could figure out interesting things happening on a city or a country scale. And so, in fact, that is becoming possible. So you can, if you could track the population on the city scale, then you can match the population to other external data, like medical data or environmental data, and mine that to improve social services. And maybe in Christchurch with the rebuild, if we knew where people were now travelling, then that could be used to improve the roads in certain places, or if we knew where the accidents were happening, things like that. So about 10 years ago, I guess it was, MIT Media Lab, through their Sensible City project, they had a professor that wanted to be able to track population of whole cities, in particular Rome. And he said, well, we just need a device that everybody will carry that will tell them their position, and then we'll know, but that's going to be really expensive. How do we build these devices that are $10 or whatever and give it to everybody in Rome? And they suddenly realized that at the time, most adults in Rome had a cell phone. So if you can work with a telecom provider, track the cell phones around Rome, then it gives you a population dynamics of the city. And they did that. You can do it in an anonymous way. Of course, there's lots of social issues around that. But so here's a heat map of the population of Rome over a course of a day. And so you can see at 4 o'clock in the morning, it's almost empty. Then at 8 o'clock at night, the people start flowing into Rome as well. And we did a project similar to this with in New Zealand with Telecom. Telecom gave us a few gigabytes of data showing us mobile phone patterns moving around Auckland. And you can do the same thing as well. Then, of course, it's not just about what people where they're moving, but it's also about other information as well. So the most recent version of that is a Sensible City Lab, this thing called WikiCity Rome. And the idea was not only just to track people from their phones, but also look at the digital output that people are making. So when I send a Twitter message, or I do a Facebook update, or a blog post, or anything like that, then you can see that output being generated and then overlaid back onto the city map as well. And so you can see with wearables, then you're just taking that to the next level. So now you've got somebody who's wearing the computer, who's got sensors on here, a camera, audio input, and now you can catch a lot more richer data and then take that back out as well. So if you imagine a scenario where you've got some significant portion of the population wearing a computer like this, then you can get some very interesting data from that. For example, this is a project done in Africa. So the mobile phone company Orange were interested in what you could get out from mining large amounts of data. So they made available an anonymous data set of 5 months of phone calls from the Ivory Coast. And I think the data set's still available, so it was 2.5 billion phone records, but all anonymized. And then academics could request the data and use it for projects, and there were 80 different sample projects that were being used. And one that was very interesting was using this to model the flow of disease in the Ivory Coast. So it turns out if you can monitor the mobile phone patterns, you can know the movement of people through the country. And in some ways, so you can if people are traveling on the roads, they travel faster. If they're traveling by foot, they travel slower. If they're traveling by boat, so you can make a network of all their movement patterns, and then you can use that movement pattern to predict the spread of disease. So this is a prediction of the spread of AIDS in the Ivory Coast. If a person got AIDS or some other highly infectious disease, and in the capital, how long would it take to spread throughout the whole country, and what would the spread pattern be? So you can imagine that wearables will play a big role in that as well. And then the last thing I want to talk about is, which we've skimmed through a little bit, is the social consequences. So what is going to happen when people have lots of wearable devices on them? And there's huge privacy and social issues around. And so there's this really interesting video that was made by a group of people from Israel called Sight that talked about that. And so I'll just show you a little bit of a clip of it. It's a longer video, it's 8 minutes, so I won't show the whole thing, but I'll just show you a snippet at the beginning. And if you like it, you can go and see it for yourself. But it really addresses the issues of what happens when the people around you are wearing technology that's invisible, connected up to intelligent networks at the back end or things like that. So let me see. Here it is. So you start seeing the guy, and he's doing something strange initially. Here he is. Looks like he's kind of rolling around on the floor. But actually, he's got the contact lenses on, and this is what he's seeing. So he's playing a game right now.
Good job. Excellent. Well done. Well, that was complete.
That's his exercise for the day. So now he's going to go and get some food. And with it, you can see in the eyes are kind of glinting a little bit. That's his contact lenses. And now the lenses can turn the world into kind of a game. So now it's telling what's in the fridge. And he's got the cucumber. And he's now going to chop the cucumber. But he's going to get points. He's got the Chef Master game that gives him points depending on how well he cuts the cucumber. So now he's getting points from that. Uh-oh, I lost the life on that one, so now she's a new. Needs to restart and start all over again. I'll fast forward a little bit. So the egg, he's got to put when he's frying the egg has to go into the spot there, and you get points for that and everything. So.
Snail zombies from your backyard.
So now he's going to go. Let me go back here a little bit. So he's going to go on a date now. That was getting ready for the date. And it turns out he's not very good at dating. So he has this app called the Wingman that he can load up that tells him how to make good conversation and be better at the date. So this is what he's seeing right now. And you'll see in a minute he's kind of looking at the stars, being distracted. And his date turns up. This is an astronomy app, so he can recognize the star constellations. And then you'll see this kind of awkward conversation that he has until he turns the Wingman on, and then it gets much better.
Look great.
Thank you. Love your jacket.
Thanks. It's a sports jacket, so it's a lot less official than it looks.
What do you mean?
Sorry?
What's the difference between a sports jacket and a normal one?
He's the Wingman.
I guess a sports jacket is for people who want to look good even when they're chased by the police.
Hard difficulty, so she's got to be good. And this is what she's seeing, saying another bad day, and she starts posting to Facebook.
I hope you're hungry. This place has the best burgers in town.
Oh, actually, I'm vegetarian.
Oh.
Yeah.
Really? Because you didn't say it on your profile, so.
Well, I don't write everything on my profile.
She's getting irritated, so she's recognizing that.
We're going to go somewhere else?
No. It's okay. I'll find something on the menu.
Well, how about a glass of wine for starters?
Yeah. Great.
So, are there any other things in your profile that you didn't write about that I should know, or?
Anyway,
Are you scared of doggy talking by yourself in this?
I won't play the whole video, but it has this kind of interesting twist at the end. So definitely, if you want to see what potentially some of the negative consequences of wearables are, you should watch and have a look at it. Yeah. So that's about all I wanted to say this morning. But we're going to get some feedback from some of you guys. So in your experiences with glass over the last week or so, and of course things you've been thinking about or reading about and looking at, what do you think are some of the important areas that should be addressed in terms of research in the future? We had a little bit of conversation yesterday about what you felt about the user interface and user experience of glass, and you can see that there are many other experiences coming out with other devices as well. So what do you think if you had $1 million to invest in research and wearables? Where would you put the money, and what do you think are the important questions to be solved? Does anybody have any thoughts on that?
Well, I guess one of the things from a sort of research perspective is in terms of software development, the kind of thing that we do is we've gone from having to trouble over to the mainframe with lots of cards to having a PDP in the department, to
right.
having a machine on the desk, to pumping these sort of things around. The way our development practices are going with all this is helping us do more team kind of things. The way things are going to be working much more efficiently. This kind of stuff helps with those things, but again, it's a step in that progression away from the technology. So I'm interested from a research point of view and how those kind of things can help in that slightly more formal setting. The whole outside of the real world is another thing altogether, which we're probably least qualified for.
Well, I noticed when I was at Google, that's a really good point. When I was at Google working there, there are most of the people in the glass team, of course, would wear glass all the time. And a lot of people used it for providing a secondary monitor of information. So they'll be doing their coding or whatever on their laptop or desktop computer, but they'd have their email stream going through glass. So that didn't, I noticed that when I'm programming or doing some task, oftentimes I'm dividing attention. So I've got my email window over here, my code window here, and they're splitting attention like this way. And it's really hard to refocus, but with glass, you could have the whole of your desktop could be your coding, and then you've got the secondary channel of information, and you'd see the titles of the emails coming through. And if one was particularly urgent, then you could look at it. And if you need to, you could then pull up your email client on your desktop and really read through it. But it was really interesting watching people working with that multiple channels of input. And then I was also interested in meetings where you'd have people wearing glass the meetings would now become a lot more face-to-face. So like we've got here, oftentimes you've been to meetings yourself where everybody sits down, they all open the laptops up, and then you've got no idea what's happening on those laptop screens. They could be paying attention to you, they could be playing Angry Birds or Facebooking or coding or whatever else. Whereas in Google, when we were there, there was still a little bit of that going on, but oftentimes it would be everybody wearing glass, and some of the things they would do normally on their desktop, they would see their Facebook updates or emails coming through the glass, but they wouldn't be distracted from the meeting by that because they were still heads up into the meeting. So I think that what you're talking about is a really interesting area to look at. Have you got anybody else got any other thoughts about important research directions?
I sort of see wearable computers as being like an operating system over the world. So kind of like everyday devices that we interact with all have their own kinds of interfaces.
Right.
Whereas a lot of these things are sort of showing like an alternate way of interacting with those things.
Yeah.
Maybe a better way. And so I guess that would be probably quite interesting, is all the different ways you can interact with everyday devices. So things like refrigerators in that video, and just like even like mundane things like your car could give you different kinds of input it couldn't give you before.
Yeah, that's a really good analogy because, I guess 20 years ago when you were using computers, you oftentimes had to deal with individual device drives, the devices in your computer, and in many cases you build it yourself. But now, hopefully you go to the store and you buy your Mac or Windows computer or whatever, and that's all hidden from you. It's just obvious that it sits on top of all the device drives and everything else. And if you take that back to the world scale, like you're saying, now you've got these, I guess it's called the Internet of Things. So you've got lots of devices now that have their own internet connectivity. And sometime in the future, if you want to have this kind of seamless vision, which they show here in the site, my glass has to be able to talk to my fridge and the thermostat in my environment, my car and everything else. But we're still a ways from that, but that's a very important area to do research on. In fact, I think in Europe, the Internet of Things research effort has been funded to about 20 billion euros over the next 10-year program. I think they've got the Vision 2020 program that is set out, and they're picking a number of big areas to invest heavily into, and one of them is in the Internet of Things, which I think they put $20 billion into, or 20 billion euros, so $40 billion into that over 10 years. So, people are definitely interested in that area too. Anything else that jumps out at you?
So one of the things that's expanded hugely since mobile phones come into the marketplace is trying to get sensors to talk to yourself and where you are and people around you, and all sorts of private sensors like your health, how many steps you're walking, Bluetooth about that, and you've got antihistamines, other ones with your heart rate, and all that sort of stuff is going to expand into private wearable devices will let you monitor a lot of that stuff itself.
Yeah, that's interesting. Anything else?
I guess some social aspects that need to be resolved at some point.
Yeah.
Getting government buy-in would be important. Moments people being dragged out of cars and movie theatres just for wearing Google Glass.
Yeah, definitely. And it was interesting when I was at Google. They didn't really have anybody on the team that was an anthropologist or anybody that they had a lot of marketing people, but they're not really the people you want. You want people that will actually think and sit and watch how computers are being used and giving feedback. They didn't have any ethnographers as well. So there's a lot of interesting studies that's been done on how people's behaviour changed with cell phones. And I think there's still a lot of work to be done in that area with wearable devices like this as well. I guess Google's model, and this is a beta test, their model was basically put it out there and test it, like done with Gmail and the Chrome browser and things like that. So they're trying to do that now with the hardware. And we're seeing interesting social effects. People getting kicked out of pubs or whatever for wearing display.
Has there been much media pushback on Google Glass? I saw something on today, article about
Glass hole, yeah. So one of the, I don't know, do any of you know Robert Scoble? So he's a Silicon Valley blogger who's very, very popular. And so he's famous because, if I go to my web browser here, so he was one of the early glass explorers. So if we type his name into, I bet almost $100 that you'll see a picture with Robert Scoble in the shower. Let's see if we can find it. There he is. So he's famous because he got his Google Glass and he wore it in the shower with him about 2 days after he got it. And I was in Google when this happened, and the marketing team were just horrified because until they released Glass to their developers, they had very tight control on the marketing platform message. And the Google employees, for example, were told. I went to a conference and I was told that nobody was allowed to have their picture taken wearing Google Glass except for me, and I had to look happy and excited all the time that I was wearing it. And so you can imagine they released the product to their core, the Google I/O developers, and then a day later this appears on the internet. And but he was very, very excited about Glass when it came out, and he was saying it's so exciting, and he does a lot of conferences, he's wearing everything he got. And now about a year later, he's now he's basically a month or so ago he posted a blog post saying, well, this is the good and bad about living with Glass for a year, and he was much more neutral and even a little bit negative now. So I think I think many of you may know the Gartner hype cycle, where you've got this kind of curve like this, where you get a new technology and it drives up this plateau of heightened expectations, and then you've got this big trough of disillusionment, and then eventually you get to this actually they call it the plateau of productivity, where it actually becomes. So when the first devices come on the market, it's like when you've got a hammer, everything starts looking like a nail, and you figure it's going to solve the world's problems. And so in many ways, the wearables is kind of still going at that plateau, and I think we'll go through this crash in a year or two where people will realize that this device isn't going to solve all the problems. But then after that, you'll identify a very profitable niche areas where it can work properly. So I think we're kind of heading down, and the idea is you want to go through that cycle as quickly as possible, because then you you don't want to be like the AI winter where in the 60s, or when they first invented the first chess playing AI or drafts playing AI apps, they figured that within 10 years' time would have language translation and would have all these amazing things, and then they realized actually the things that they thought they could do were really hard problems, and they went to the whole plateau, and then they troughed, and it was, I guess you lived through that, Neville. I mean, not sure, it was probably 20 years or 15 years of where AI was kind of a bad word, and they started to call it things like expert systems or knowledge assisted, whatever. So you want to go through that as quickly as possible. So I think now with wearables, we're riding up that peak, and hopefully we'll cross down to the trough, and it'll only take a year or two to get through that, and then in 4 or 5 years you'll identify the areas where a lot of the productivity is going to be. Okay, well, I should stop. I've been doing a lot of talking, I went over time. So might be good to have a bathroom break now, and then Gun's going to... Oh, that's right, the picture, yeah. And then Gun's going to take over and talk a little bit about what we've been doing with augmented reality on glass. And we've released a free SDK that people can download and build simple AR apps that use the compass and the GPS, so you can walk around the real world and see a little bit like what you're trying to do with your app there. So he'll show you how to do that, and he'll show you a few live demos, and then you guys are free to program some more.
Are those slides on Drive?
This is not yet, but they will be in about an hour or so. And also ones from yesterday I haven't put up yet. I've been pretty busy getting ready for going away, but they'll also be up here as well in the next hour or two. And you're free to share them with whoever you want.
And then I'll maybe give you a slightly more detail about, depending on how much time we have for lunch, about a software library that we've built in our lab, which is a small library that helps you build outdoor AR applications quickly. So maybe I'll give you a little bit more detail about how to use that library, and then maybe that will be it. And hopefully we'll finish 5 or 10 minutes before 12, so that we can clean up the space a little bit for lunch. Okay. So first of all, this is a website. I'm not sure if you have had a look at this website. I'm pretty sure if you try to launch that website, it will not connect. Or yeah, but it looks like this. This is how it looked like this morning. Before. Unfortunately, our web server got hacked a couple of days ago, and our IT manager is currently going through some management stuff, so it's a bad timing. But at least I had this loaded up this morning when it was working, and we have a couple of projects or tips you can look on our website, this AR4Glass website, and have a couple of demos, actually some APK files you can run on either on glass or on a smartphone, Android phone, so you can quickly glance how these type of AR libraries work on glass. So let me just show you a couple of demos that's available on our website, although the website is down at the moment. So if you go to our website and go to the projects, I will not bother clicking it. There will be a couple of projects that shows up, that explains, that has some sample APK files that you can run on glass, and that uses AR libraries. And one of those is using this NIR toolkit. If you type just NIR toolkit in Google, I'm pretty sure this will be the first page popping up. And this is Java-based AR toolkit, which uses this type of square markers, and you can, since it's written in Java, and it's actually a port of C++ version of AR toolkit, which Mark did his PhD on it. So since it's a Java version, you can easily run on Android, and they provide an Android version of NIR toolkit as well, and it's quite simple library you can use. If you're interested, you can try that one. Let me show you it running on the glass right now. And if our website was on, then on the website there should be all the command line commands that you can use. ADB, which is included in your Android SDK to install the APK file and to run that. But glad that I have a copy of those here. So first we'll install. Just to quickly explain, it's in ADB. You can type ADB install and then Nair Toolkit APK, and it will start installing that APK on our class. Unfortunately, this sample application we didn't modify anything, which was available on Nair Toolkit's website. So it doesn't have a voice command. So to run the voice, to run the app without voice command, you'll have to run this command, which is am start. And I'll turn the class on. Then it's running now. I forgot to run this screencast. Okay. So as you can see here, the frame rate is quite slow on this screen, but it's not too bad on the glass. If I print out this kind of sphere marker and try to look at it, you can see it overlays a kind of OpenGL cube on top of this square marker. So as you can see here, Nair Toolkit quite works well on glass as well. So if you're interested in doing some kind of AR application that runs on a desktop setting with some markers, then that's a good library you can use. The other library is more widely used this day, which is Qualcomm's Vuforia library. And this is their website. So, and they have quite an advanced technology, such as detecting these kind of photos that has rich textures, or recently they've got some more improvement that you can actually track. You can start tracking from the marker, but you can also go away from the marker and will still pick up some image features from your environment and keep tracking. Just run. And the demo I'm just going to show you is just a plain sample code of theirs and Vuforia. And this sample APK, we've built it and uploaded on our Air or Glass website. So if you want to try it without building it, you can do that. It's virtualbuttons.apk. Then, and all these ADB commands are on the website as well once it's back. It's virtual buttons. Stopped. All right. So again, it will start with picking up some camera image like this. Then if I look at a piece of paper that it's programmed to track, as you can see here, I can see a teapot. And then you can also tap on some physical buttons, the virtual buttons that's overlaid on top of this marker. So you can point at some buttons and the color of the teapot will be changing accordingly. Green, so it likes the yellow color. But anyway, as you can see here, these types of, as you might have already expected, these types of libraries works quite well on Glass as well. So if you plan to have these types of desktop-based AR applications, then Vuforia or Nair Toolkit might be a good starting point, so that you can build your application and test it on your phone, and later on you can easily run that on Glass as well. So that's our AR for Glass website. Hopefully it will be back later today. And the main thing I'm going to talk today is our Outer AR framework or software library that we have available on our website. This is our link to that page. You can download for free, and it's an Android library so that you can use it, and it runs both on smartphones and glass as well, so you can start building some AR applications, especially outer AR applications which uses GPS and sensor information to overlay 3D graphics in the real world. So how many of you have tried one of the AR browsers on the smartphone? Yep. Anyone? So, since the smartphone came out, the iPhone and the Android phone, people started building this type of AR browser applications, which overlays tags or simple 3D icons in the real world and roughly tells you where about the things are, although it's not super accurate compared to these types of computer vision-based tracking. But since we cannot really track everything outside, these types of applications have been gaining some popularity, although it went down to that technology hype curve that Mark mentioned. Anyway, we can easily do this stuff on these kind of browsers. These browsers does provide some APIs or libraries by themselves, but they're quite limited to run those contents on their own browser, so that you cannot really do customization with the interface of your app and sort of things. So what our library, the Outer AR library, provides is more flexibility so that you can customize the user interface, and you can build in your own application logic so that you can build either a game or a information browsing type of application and sort of things. So it's more flexible, I would say. So these are some of the applications we've built with our library, and some of them are available on Android Play Store. So if you're interested, you can download it from there and try it out on your. Why is this wrong color? This is showing in wrong color. I'll try to run it again. It's totally wrong. Maybe my laptop is struggling with low memory. I'll just go to folder, try to run it here, run true CTUR. Let me actually run this video clip, which shows it running on Google Glass, although it's quite similar to the version. So as you can see here, this is, by the way, Cashel Street, down the city center of Christchurch. And in Cashel Street, many of the shops are, the buildings has been demolished, and the shops are now replaced with these types of container boxes with shops inside. So what CityVR does is it shows 3D models of the old building. As you can see here, this is the screen on the glass, and kind of show roughly how that street might have looked like before the earthquake. So, and as you can see, as the user turns his view, it shows the name of that building or the address of the building that used to be there. And if the user taps one of that building, it will show you some more information or historic stories about that building, so that user can swipe through or use their head to scroll through the page. And then once they're back, they can also view some panorama pictures. In this case, you can pick one of the icons on the real world that represents panorama pictures, and it shows the panorama picture taken right after the earthquake at the same spot, so that you can see how that street might have looked like right after the earthquake. And this is another example showing the big building that were used to be at the corner, and which is now just empty space with a car park. So that's a type of application we can think of. I'll show you just one more example, which is kind of game application, and this was originally designed to run on glass, but this video clip is just running on a phone. So this is an app. It's a kind of location-based gaming app, and we kind of designed it to be encouraging some walking outside. So it starts with the map view, and it shows your location, and it makes some sounds, beeping sound, and as you can see here, it shows some icons of these mysterious creatures that you can find there. And as you get closer, it will make more frequent beeping sound. And as you get to that point, let me scroll. And then it will say you found a flock of geoboys, and it will start an AR view. As you can see here, you'll find some big creatures flying around, and you can actually capture them. We didn't want it to make a violent game, so we made a concept of capturing them. Originally, we was thinking of throwing a net with this glass pad, so you can, although we are swiping on a screen, on the glass it should work like swiping on the touchpad, and you throw a net, and then you can capture them back. But we're still working on that one. And the other thing we were thinking of was to integrate some more cool interaction that we can think on the glass. So one was using voice input. So what we did was we kind of made a small pitch detector, so that when people whistle in a correct pitch and in a correct length, then the geoboys will get scary and then flock together. So let me show you to make it easier to capture. So let me scroll a bit further. It was somewhere here. Yep. So as you can see here, here's a small meter showing how well you are whistling. I think, where's my mouse? So it will show you how good you are whistling. So it's too high. And then they will get scared and then get together, and then you can easily capture them. So, and the other, although we haven't still implemented it, the other idea we had and we are trying to implement is them attacking yourself. So your screen will be filled up with some either some goozy things, and then you have to shake your head to take over them. So that's kind of example applications that you can build with Outdoor AR framework. And as you can see here, you can pretty much customize whatever you want on the screen and the way you interact and the flow of the application logic. So it's quite flexible compared to other libraries that are out there for outdoor AR. So I'll just briefly go through some of these, some of the details, and then maybe show you one demo that outlines how to code it. Then, so we have a kind of library that runs on the client side, but what we also have is a server-side code, so that you can deploy content on the server and even set up your own server and deploy content through that. And the server software kind of gives you a RESTful API interface, and it also comes with a web-based authoring tool that looks like this, so that users can easily drag and drop 3D models onto the map and type in some descriptions of it, and it will appear on the and either your application or some standard browser application could load those 3D scenes. On the client side, it provides an abstraction of not only AR, but also the map view and the list view, which is quite common on outdoor AR browsing applications. So you can use the same underlying scene data this map and list view will easily take those same data set and load up without any coding in the Android library level. So it's a little bit handy when you're building like the geoboys. You can easily use both map and AR view components so that you can integrate them together. So with customization, you can customize each scene. So we have a class called OA scene, outer area scene, that basically has a name and description of string, and then you can describe the latitude and longitude of scene, and then you can add a 3D model and it will appear at that place. But the good thing is that you can actually extend that class and add your own data structure to that, so that you can use, if you are building an outer area application for zoo or something animal, then you can add some data structure telling about that animal or a plant or something. So that's one thing you can do with outer area library. And the other thing is you can highly customize the user interface layout by yourself. And the way to use this library is as simple as creating an Android project, and then our library comes as an Android library, so you can easily add that to your project. And then maybe I'll just briefly show you how to do that right now. And then, so we'll start with a Eclipse project. And by the way, the library itself and the sample code I'm going to show you now is all out on the shared folder. And also, the library itself is also downloadable from our website, but it's down at the moment. So if you open up the Eclipse, it's taking to build something. All right, then what you can do, of course, you have to download those library in the source code. And what I'll do is just simply import. Oh, by the way, the first step, it has some dependency on the Google Play service, because it's also using the map library that's provided by the Play service by Google. So the first step you'll have to do is import that Play service. And the way you can do is you can go to import, and then choose Android, existing Android code. And then in your SDK folder where you installed your SDKs, for in my case it's dev lib and edit bundle. Inside the SDK there is a folder called extra, and there's a folder called Google Play Services, and they kind of taken away this map component out of the standard Android SDK and providing it as a Play Service library. So, and then go to lib project and Google Play Service.lib, and then choose that one. And it's a good idea to copy it instead of building it in place, not to ruin the original source code. And then you'll have that library in, and that's all. Then now you can import the outer area library, which is, if you have downloaded it, you can click existing projects, then click next, and go to, I think I had it in download, outer area. And if you have downloaded, unzip it, your folder might have two of them. So you first import that library. And then there is one more dependency that you'll have to add, which is the Android support library, which again has to have for the map UI. So for that, you'll have to go to, again, dev lib, that's where I put my Android bundle. Inside the Android SDK, again, go to extra, this time Android support, and there should be a folder called B4. There should be a jar file there. So you can drag and drop this file to the libs folder of the library itself. Okay. And by the way, these steps are always explained on our website, so don't worry too much about setting up. So once that you've got those dependency libraries running, then the other thing you can do is import the sample code, which was right next to the outer area library. and run it. And this sample code has all the sample components, including the list and AR and map, and shows how to use them. And this is on our website, so I'm not going to explain that one. But coming back to our website, so that's how to set up the development environment. Again, those are available on our website, so don't worry too much about it. And when you're building your own project, there are a couple of things you have to be aware of. And one thing is, again, permission. So if you're going to use GPS, again, as I mentioned yesterday, you need to state that your app is using access to GPS locations in the Android manifest file. And also, the other thing you'll have to be aware of is that our library also accesses some cell information. Let me show you actually what the manifest looks like, the sample code. So these are the permissions that you need to run Google Maps based interface, map interface. And these are the permissions that you would need to run. It's basically accessing locations and the camera so that you can show the camera background. And this is for keeping the screen on and not time out when you're not active. So, and one thing is that you'll have to inherit your activity from OA/AR component base, which is a class we provide in our library instead of the standard activity class in the library. And once you've inherited that, this class will provide you with handling most of the Android side things so that it will be easier for you to implement an AR application. So another thing, you'll have to prepare 3D models. Currently, the library can load OBJ models, and I think there is another type of model called Q something. I can't recall at the moment, but it's described on the website, so please refer to that one. And it uses OpenGL coordinate system, which is just like this in the real world. And the -z direction is pointing to the north, so it should be that way like this. So if you place on a model in certain lat long, and if you load up something, a 3D model, then that you modeled on your modeling package, such as Maya or Blender, which is a free one, then the XYZ coordinates should look like this. And placing it on a real world, this website is quite handy, where you can actually just click on a map and it gives you back the latitude and longitude of that place. So this is that website. So if you click on certain place and then click that, then you can simply copy that and copy to your code. So that's handy. So, and then you add that to your assets folder in your project, and name your model in a folder, and then put the OBJ file. And what you have to override this time is on setup scenes is where you can add scenes to your application. On scene selected is when it will be called back when user taps on one of the scenes, and you'll get what scene the user has tapped. So you can do something like showing more detailed information, or like in the GeoVoids game you've seen, we are just simulating the tapping event and getting which GeoVoid was tapped on and kill that one. And okay, also you can use some of the functions we have in our libraries, which you can mark your location to certain places so that you can test your application as well. So you can describe the scene by code either or using SQLite database file or XML. So you can easily change your scenes without changing your code. Again, OA scene is a class that describes the scene with, you can describe lat long and 3D model sort of things. I'll go through those. And to use the map interface, you'll need the map API key from Google. So that's the place you can get those. So I'll just show you a project that I've put together for this tutorial and explain a little bit more detail, and then just show you that running on the glass project. Then this code is up on the shared folder again. So it's tutorial, no, class, tutorial projects, and it should be called OA tutorial. There we go. So don't worry about the main activity. This was for demoing purpose. So as you can see here, the OAR component base itself overrides other methods such as onCreate and sort of thing. So it handles putting the layout for you. So you don't really have to override those in case you're building this app. And instead, you might want to override some other functions that the library provides so that you can set up your scenes, like creating a new scene objects and then putting a let long and the name of it, and then add it to the data manager, which was passed to yourself, so you don't have to worry about setting those up. The library does everything. And you can also override on some methods, like such as on touch scene method, which is called back with the scene that's touched on, and then you can either give a toast message, or in this case, we change some text on the info panel text, and then and show the name of that scene, sort of. And in setup UI callback, you can set up your own UI layout. So if you want to add some labels on the screen, or in this case, I think I had some reticles so that you can aim at the scene while you're running on Google Glass. So you can define your layout in the XML file as you normally do with your Android project, and then just load that and tell the library that you're going to use that layout. Then it will be overlaid on top of the AR background. And other things you can do is to make it more friendly to run on Google Glass, you can run a kind of background timer and kind of simulate as if you are tapping on the middle of the screen, so that you can get the scene called back to your on touch scene function while you are aiming at it. So let me just run this one on Glass and just show you how it runs, and maybe we'll wrap up this session. So click run as Android application, and hopefully it will not complain with any errors. Hello. Still launching, still launching. It's building. There we go. I go back here. So as you can see here, I made it to start. I get stuck. Got kicked out. I think I made it to run it without the background. Setup options. Just try to run it again. It's not showing the camera. Maybe I'll have to reboot this class. Can I grab that white one, please? I think something I ran with the other air demo. It's keep holding the camera. So I'll do it here again. Hello. To run this one as well. It's running on my glass, but stopped showing on the. So as you can see here, it will have a camera background, and if I look around, there should be some icon somewhere. Maybe better this side. So if I look at the cube, then it will show that that is a cube. If I look around, there should be another cube there. Then there's a small basketball flying over there. So as you can see here, you can write quite easily an AR app that could run on Android devices, including Google Glass. So, couple of tips. It's again, it's easier if you rather make it to aim to select it rather than require to tap something. So the thing is, as I've shown you in the code, you can run a timer and force to have a clicking event at the middle of the screen, and that could do the trick. And on generic motions, you've already have been playing with this, so I won't mention too much. And you can also think of head motions, as I've explained earlier, with geovoids. And again, GPS on glass is not available, and you'll have to pair it with the phone. Other thing you can do is use on the application you can use a mock location, and then what you can do is write your own application that streams the GPS location from your phone through Bluetooth, and it's quite easy. And here's a link to a sample of where you can grab a sample code of having a Bluetooth chat sample for Android. So if you modify a little bit, then you can easily stream whatever data you have on your phone to the glass easily. And that's what we actually did with the city viewer for that. So let me just briefly show you how city viewer looks like on the glass, and maybe we'll finish today. So I've keep closing this. And by the way, this city viewer APK is for the glass is also available on our Air for Glass website. So, OK Glass, city viewer. So it will start with looks quite similar to the other sample I've shown you. I think it's still loading some building models, so that's a bit responsive. You can either turn on the camera or turn off. In this case, I'll turn it off because it shows you more clearly what buildings are around. If I turn around, you can aim at the building and it will show you what building it is. And if I turn this way, I can find some icons floating up there. So if I aim at it, it will say panorama. If I tap on my touchpad, and will load up the panorama picture that's taken at the same spot. So you can look up or look down and turn around and have different look at the place. So that's City Viewer. It's again developed using the same library. So that's it for today. If you have any questions, maybe just ask me or just talk to me over the lunchtime. And I think both this one and this one has City Viewer on it. So if you want to try yourself, just say, OK, Glass City Viewer, and we'll load up. And that's all for the lecture. And maybe after the lunch, maybe you can start preparing some screen captures of your app. I'll show you after lunch maybe how to do that and help you to do that. And maybe we can wrap up this session today. So thank you. And let's maybe, I think we're going to put food in this desk. So maybe